this is Miss Wiley, Mr. Young Student Teacher, and I'm going to be going over a graph open response review from a previous AP exam, to get your A3 AP exam. This has to do with a lot of Calculus 1 material, so this will be a good review for you guys. So we have a problem here. Let G be a continuous function with G of 2 equals 5. The graph of the piecewise linear function G prime, the derivative of G is shown above for x equals -3 to x equals 7. So as you can see in the problem, we have a graph of G prime. Now, what do we know about a graph of G prime? A graph of G prime means that we have a graph of slopes. Now, what does that mean? That means that when the line or function is under the x-axis on a graph of G prime, the slope of the original function is negative. So from -3 to -1, it's negative because it's under. From -1 to 1, it's positive, and so on and so forth. So let's look at what the first problem is. So find the x-coordinate of all the points of inflection of the graph of y equals g of x for x equals -3 to x equals 7. Justify your answer. Now, as you can remember, inflection points are something that you find with the second derivative, g, or g double prime, however you want to say it. But we have a graph of g prime. Now, what do we know about a graph of g double prime? The graph of g double prime, the second derivative, is a graph of the slopes of the slopes. So what that means is that we're going to look at the actual slope of the line of a graph of g prime. So when we look at the actual slope, we can tell that from -3 to 1, it's positive, so it's growing or increasing. And then from -1 to 4, it's negative. And then from 4 to 7, it's positive. So that's the actual slope of the lines. Now, with inflection points, we know inflection points is where concavity changes. So when we look at a graph of G prime, it's going to be where the slope changes on the graph of G prime. So the slope changes at 1 and at 4. So that would be your answer. So for this problem, we have x equals 1 and x equals 4. I'll ask for justification, and all you need to say is because this changes, it changes from positive to negative. And same thing with this one. G prime changes from negative to positive. Right. So that would be your answer to the first question. That's it. That's all you have to do. If you do those steps, you'll have all your points. Pretty simple. Second part, find the absolute maximum. Let's underline maximum here. Find the absolute maximum value of G. So G, not G prime, on the interval x equals -3 to x equals 7. Justify your answer. So now we have a graph of G prime, right? So let's find where a maximum is of G prime. So a maximum, we know, is something that goes from increasing to decreasing. So as we do what I said before, so where on the graph is it going from increasing to decreasing? So the only place is that something that goes above the line goes above the x-axis to where does it go below the x-axis? And the only place it does that is at 2. So max goes from positive to negative. So the only place it does that is -2, because that's the only place where the line is going to go from above the x-axis to below the x-axis. So when we do our answer, so we have to consider g of 2 as a point. This one here. And we know already from the problem that g of 2 is going to equal 5. But we're not done, because you always have to consider the endpoints on these problems. Always. So we also have to consider what is g of negative 3 and what is g of 7. So how do we find g of negative 3 and g of 7? Well, how do you get from g prime to g? You use integrals, antiderivatives to go backwards, right? Now, on a graph, the antiderivative is also equal to the area under the curve. So we're going to do g of negative 3 together, and then you can do g of 7 by yourself. So we have an integral. Now you always have to add 5 because that's what it is at negative at 2. At 2. So you always have to add 5, even on the 7 one. But you add it outside the integral. Now here is going to be the integral from 2 to negative 3. So because you're going to go from 2 to negative 3. Like that. For g prime of x dx. Now, how do we find what g prime or g is going to be equal to? Well, it's going to be the area under the curve. So when we look at here, so we have, luckily for us, it's not pretty geometric as the graph is, so we don't have to do a bunch of different little equations. We can just split up into triangles and add their areas. So we look at the area of the first triangle. We have 2 by 4, 1/2 base times height, we give them 4, and then the 2 on top, it's going to be 1, and then this one will be, when you add them together, add these two together, it's going to be 3/2. So we have 5 plus, now let's see, negative 3/2. Why is it negative 3/2? Well, it's negative 3/2 because it is left, it goes backwards from 2, from our point. And if something goes backwards from a point, it's negative. So it's negative 3/2. But 4 is positive. So why is it positive? It's because the 4 is under the x-axis, which also makes it negative. So you'd have a negative negative, making 4 a positive in your equation. When you add these together, you're going to get 15/2. So g of 3 will equal 15/2. And you can do 7 the same way we did negative 3. Only thing is, just keep in mind that going this way to 7, everything is right to. So if there's something above the x-axis, it's going to be positive. But if it's below the x-axis, it's going to be negative. So keep that in mind. And we get down to answering your problem. So, g of 7 is going to be 3/2. So when you look at your problem here, you can see that the biggest y value is going to be at g equals x equals negative 3 at g of 3. So when you come down to answer the problem, you have to state that you considered 2 as a point. So you consider 2 as a point because of what we said on the graph, because it's the only place where it changes from negative to positive. And that's pretty much it. You have to do the work we did up here for g of negative 3 for both negative 3 and 7. You don't have to do it for 2 because it already gives you 2 in the problem. and then you just say the maximum value for g um, for the intervals x equals negative 3 to x equals 7 is 15 halves. And that's it. If you do all that, you get your points. So find the average rate of change on the interval negative 3, x equals negative 3 to x equals 7. This one's pretty simple. Now, you might say, oh, g of x is going to have to do the antiderivative, but it's not. You can just use what you found in b when you did the antiderivative up there for what we're doing now. So we can use this one and this one. Now, what you're going to do is it's going to be g of 7. G of 7 is minus g of negative 3 divided by 7 minus negative 3. We do that because we want to see how many units. So if you put negative 3 and 7 on number line, there's going to be 10 numbers in between them. So there's going to be 10 spaces, 10 units. So I don't even want to think about it. Between negative 3 and 7. So we're doing this one. You're just make sure you write out your equation. So let's do it here. So you're going to have g of, so for this one, g of 7 minus g of negative 3 divided by 7 minus negative 3. So we look at, so we know this is going to be 10 already. And we look at what we have up over here that we found in B, and 7 is 3 halves minus 15 halves. And that's going to give you negative 3/5. So the average rate of change is going to be negative 3/5. And if you do this part right here, just all this part, you got all your points. So that one was pretty simple. Now finally, so we're doing the average rate of change again, but for g prime on the same intervals. So let's just work on that first. This is pretty easy. Where are the y values of same equation? Just have to do the y values on this. So we know that at g prime of 7, we have y equals 1, and at g prime of 3, y equals negative 4. Still 10 on the bottom. When you do this one, you're going to get 1 half. So that's part of your points. But does the mean value theorem apply on the graph we have? Guarantee a value of c for c equals negative 3 to c equals 7 such that g double prime of c is equal to the average rate of change. Why or why not? So I'm pretty much asking you, is the mean value theorem going to guarantee the existence of the value of c, pretty much? So, like, is it going to work? And the answer to this is no, because the graph you have is not differentiable at all points. Now, if you remember when you started studying graphs or whatever, that you cannot, it is not differentiable at points such as these right here. And since there's at least one of those on the graph, the mean value theorem is not going to work. So you do that and you write no, the mean value theorem, and write why. It's because there is at least one point where it's not different, you can't take the derivative, then the mean value theorem is not going to work. If you do those two parts, then blah, 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 blah. So if you do those two parts, you're going to have all your points. So I hope this helped a lot, and looking forward to seeing you guys in class. It's been so much fun.